of solving the given equation. So this equation you see is solved in other websites, but in other channels, but they solved a little bit differently. So I'm trying to take a different approach. For example, if we are taking this equation here, x plus y, and we equate with 2. If we are multiplying everything by x, it yields, so it's going to be x squared, x times x squared plus y times x is equal with 2x. If we are subtracting both sides by minus 2x, both sides, what we are going to get here, we are going to get x squared. But instead of the xy, I am going to substitute xy is equal to 3. So this is going to be plus 3 and minus 2x is equal to 0. Respectively, this is a quadratic equation. X squared minus 2x plus 3 is equal to 0. So this is a quadratic equation. But if we are going to solve, we cannot factor, but if we are using quadratic formula, with the quadratic formula we can find the two solutions. One of the solution is going to be x is equal with 1 plus square root of 2i, and the other solution is going to be x is equal with 1 minus square root of 2i. And now instead of the x, if I'm applying here in this equation, instead of the x, I'm applying 1 plus 2y. We can take either one is going, let's say 1 plus square root of 2i is a plus y. So instead of the x, I'm applying the solution is equal with 2. If we are subtracting minus 1 minus square root of 2i both sides, okay, minus 1 minus square root of 2i, what we are going to find, y is going to be equal to minus 1 is 1 minus square root of 2i. Even if I'm taking now, so I'm taking this one, x is this value, this solution I'm taking. If I'm taking, for example, x, and if I'm plugging here, I'm going to find the opposite. If just they are going to switch. Instead of the x is going to be, for example, 1 minus square root of 2i, but y is going to be 1 plus square root of 2i. So is going to be just the opposite. But now if I'm plugging now, instead of the x in a 5, okay, so if I'm plugging 1 plus 2i in a 5, and here is a plus. If I'm plugging here 1, instead of the y minus a square root of 2i in exponent 5 is going to be equal. So as I said before, now in this case, so for example, even if I am taking the second solution here, is going just to switch the side. This one can be in the beginning instead of the x, and this one instead of the y. So it's going to yield the same result. But before I'm going any further here to expand those binomials, we already know the Pascal triangle is in this way, for example. So just let me erase this one here. So the Pascal triangle is, we are taking the coefficient, how they can be, 1 to 1, and here is 1, 2 plus 1 is a 3, and 2 plus 1 is a 3 and 1, so this is in the third degree. In the fourth degree is going to be 1, 4, 3 plus 3 is a 6, 3 plus 1 is a 4, 1, and the fifth one is going to be this way, 1 plus 4 is a 5, 6 plus 4 is a 10, 10, those are going to be the coefficient when I am expanding this in the exponent 5. So we are going there, so I am taking care just of this coefficients here. And the other thing what I want here to mention, if I'm taking 1 in a 5, okay, so 1 in a 5 is 1. Okay, so let me write this way. Plus, because it's a plus, all of the in the front of the coefficient are going to be the positive. And here 1 doesn't matter in what power is, in a 5 or 4 or 3, still is going to be 1. And if I'm multiplying the second term, we are going to get just the second term, because here we are applying the multiplication identity axiom. And so that's why I'm taking just the second one. But the coefficient is a 5. So let me write here a 5 and square root of 2i in exponent 1. And here I'm taking plus 10 and is square root of 2i in exponent 2. Plus I'm taking, let's say here is a 10. So this is a 10 here, square root of 10 in exponent 3. Plus I'm taking here 5 in but I is here. Here is a 2, right? So here is a 2. And I'm taking a 2i in exponent 4. And the last one is a plus. I'm taking is just 1 is coefficient. I'm taking square root of 2i in exponent 5. But now if I'm taking with the minus sign, is the same, everything is the same. But what is going to change just in the second, in every other sign is going to alternate. Here is 1 in a 5, which is 1, okay? Here is a minus 5, square root of 2. So let me erase this one here. Square root of 2i in 1 is a plus 10, is a square root of 2i is square, and here is a minus 10, so every other term is going to change, is a 2 in a I in exponent 3, and here is a plus 5 in exponent square root of 2 I in a 4, and is a minus square root of 2i in exponent 5. And now we are looking what we can cancel. We can cancel those two. Then the other thing, we can cancel this because these are the same quantity with different sign, and we can cancel those here. What remains here? Remains 1 in 5 is 1, and 1 in 5 is 1, 1 plus 1 is 2. So here is a 2. And the other thing is a plus 10. 10 plus 10 is a 20, okay? And this is a square. If I'm squaring this one, is going to be 2. And it's going to be time 2 and I square. So that's what I have here. And the other thing we have here, 5 plus 5 is a plus 10. Okay, and is a square root of 2 in I exponent in the 4. And I don't have anything else. But now let me go a little bit further. 2 plus 20 is here. 2 times 20 is a 40. Okay, is a 40. But I squared is minus 1. And here is plus 10. And if I'm squaring the square root of 2 is going to be just 2. Is going to be 2 in square, because 4 divided by 2 is 2. 2 squared, 2 times 10 is 4 times 10 is 40. So that's what it's going to be. But I in exponent 4 is just 1. But if we are looking here now, so let me do one extra step. Minus 1 times 4 is minus 40, and here is a plus 40. So this cancels, and everything remains just 2. It means that x in exponent 5, so let me write a different color here, and this is the last step. X in exponent 5 plus y in exponent 5 is equal to 2, which it happens to be the same like x plus y. So this is the result.